Hey everybody, this is Larry. This is day 28. Oh, the last day of the February Legal Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Yeah, it seems like it's a problem I haven't done before, so yay, hooray. One thing that I wanted to say was, oh yeah, no bonus question today, no extra question today. I did my squats. It's a Monday, so it's a Monday squat day. And what did I do? I did 280 pounds, so for 5 reps as the first set. So yeah, so I'm getting there. Maybe one day I'll put it as as an intro video to my videos. I haven't done that in a while because I haven't traveled in a little bit, but I feel like I am dealing with it in a good place. So we'll see. Anyway, let's take a look at this problem. Find duplicate subtrees. So given the root of a binary tree, return all duplicate subtrees. For each kind of duplicate subtrees, you only have to return the root of any one of them. Two trees are duplicated. They have the same structure with the same node values. That makes sense, I guess. I feel like I've done a similar problem, but I feel like this is also a little bit hard for medium, maybe, but maybe not. I don't know. Maybe, I don't know. It feels a little bit hard for a medium, but I mean, I don't know. I feel like the standards these days for hard are pretty hard as well, so I don't know. But and maybe there's a more simple way than the way that I'm thinking in my head, which maybe requires a hard. But the way that I would think about it is actually very similar to what we did yesterday on the bonus question. So if you didn't watch that, go back and watch it. I mean, I'll go over it a little bit, but the idea is still just fingerprinting, right? The idea, yeah, it's just about fingerprinting, which, basically the idea is similar to Robin Cobb, but instead of having, say, maybe another way of, I know that Robin Cobb generally deals with arrays, but you can maybe think of an array as a linear linked list, right? Kind of, at least abstractly. And then now, instead of having a linked list, you have a tree instead, right? So that's basically the idea that I would try to do. I'm trying to think how much of an explanation that I would want to do for this problem, because the math can get very tricky. Because Robin Cobb itself is a substring match algorithm, and it can easily have, like, a long video just going on a lot of its applications and the math and how to prove and probabilistic and false positives and all these stuff. So there's definitely a lot of math that can be talked about. So I don't know how much I'm going to get into it. Definitely, I want to say that for a little bit, I will assume that you understand Robin Cobb, at least for the video that I am doing. Maybe. But the idea is, the biggest idea is fingerprinting. Maybe we don't need to, though. Let's see. 5,000 is a little bit tough. So the reason why we want to do fingerprinting is so that we can do lookups in effectively over one fingerprint with respect to Robin Cobb. Because let's just say you do a way more naive thing where you hash the entire tree every time. That's going to run up to n squared if you're not careful, right? So yeah, so I'm going to try to do it with Robin Cobb, and even though it may not be, I hurt my shoulder a little bit. Anyway, sorry friends, but yeah, let's do some Robin Cobb variation, and then we'll take a look. Yeah, I mean, we can play around with it, right? So basically here we do actually want to return the node. So yeah, so then maybe we have a sort of a scene is equal to set, right? And then now we do it, the way that I'm going to do it is that first search, if node is none, then we return. Otherwise, what do we want to do? or maybe return 0, say, right? And then as usual, maybe we have a couple of I forget what they call it in Robin Co-op. I just call it like P for power. Man, I'm actually a little bit. So maybe B for base, and then is that all really? Yeah, and for this I usually just Google a big prime. There are other, 10 to the 9 plus 7 is one, I think. That's the but I'm just gonna Google a big prime. Big, let's say 15-digit prime or something, and then I'm just pick a random number or random one. Okay, so let's say this is the base, right? And then now, let's just say left is equal to DFS node.left, right is equal to DFS node.right, right? And then now we're trying to combine the current node value. Also, maybe 0 is not a good thing because it can go up to negative 200 and 200. So maybe we'll just make it like negative 1,000 or something. I don't know. The base is also already, this isn't the, I need this is the prime, and then I also need like a shift base. So I think here we can just do like 600 or something. Maybe that'll be fine. And then here, right? Okay, so now we want to combine them in a good way. So maybe one way that you can do it is something like, let's just say node.value. We want to add 200 maybe, so that we can make it from 0 to 400 instead. In this case, then maybe we don't really need this high, but let's just make it like, I don't know, 500 then. Doesn't really matter, maybe. I mean, as long as you're consistent, it should be okay. There may be some more false positive rates, but yeah. So basically, yeah. So this, let's just say times base plus left times base plus right? And then we return v mod p, and that's the idea. Well, v is equal to all this mod p, right? Okay. If we have seen it before, if v is in seen, then we actually should keep a track of an answer, right? Then answer.append the current node. We want to add it to scene, and then that's pretty much the idea. We definitely search from the root, and then we return answer. Let's take a look. Oh, wait. I don't know how to. Oh wait, no, I was looking at the 4. Okay. Oh, whoops! I did the 4 twice. I actually didn't. I just saw that the 4 was different. I was like, why is 4 different? It looks like it's okay looking at the tree, but it's just that we need to make this. Yeah, so that if it happens like multiple times, then I guess we have to append it. So okay, so then now this is just a set, and then that's it, really, maybe. I misread the input. Yeah, okay, fine. Oh, any one of them. Okay, fine. Then in this case, let's make it a thingy. Oh, nope. Let's make this a thingy. And then if v is in scene, okay, I guess I could do it another way. Hang on. No answer. Then now, if v is not in. No, wait, what? No. We need another one. This is just annoying, but okay. So because basically our logic is that for the second one, we want to yeah, we want to add a thing, but now we're saying that yeah, okay, fine, right? And I think this should be okay. And then now we just get that values, and I think that's okay. Okay, so let's give it a submit. Oh no, I guess maybe there's a force. Did I just sort or anything? No, we just have to return any of these nodes. This is like impossible to debug, but you know, we can maybe try playing with another number for 600. Usually, you hope to at least get lucky, but if it's wrong all the time, maybe there is something more intuitively wrong about this. Hmm. I think this is a little bit awkward, maybe, but shouldn't really matter. Huh. And weapon cover is tough. I mean, I think conceptually this is okay, but I'm not quite sure why. Answer that right. We just that looks okay. I do wonder if we just do the first thing, but no, I mean that. Okay, so maybe it's not. Usually, sometimes you just get false positives, and that's what I'm testing. Is that we have a false positive? What would it look like? But now, I don't even know how to visualize this. Right? Is there like a visualizer? I feel like there used to be a tree. Oh, there we go. It's not very helpful though. But and it's all positive numbers, so I don't. It isn't like something weird with negative numbers, at least that I could see. Let's see. So what I'm looking for is something like, if it's putting zeros or something small, then maybe there's some like weird case where where like it just dedupes into the wrong thing. What am I doing wrong, huh? Should be at least relatively prime, I guess. I mean, I think it's returning the same-ish thing, but it's really hard to debug. Do I have to do it in any order or anything? We only have to return one of them. 1 to 5,000. Okay, I think we're okay here. I don't know how they sorted their thing, so it's kind of tough. We returned way much more though. Think about this for a second. The zero stuff is making it weird for sure. Because I think like it's possible that, what does this zero mean? 6 0, and then the zero should have no double no, right? So that's a little bit man, have to really think about this a little bit. So I'm returning more things than they expect. What was this? Shift twice. We have no idea. I mean, the idea should be mostly right, but maybe I mean, the code is too short for there to really be I don't know, to be there'll be a real big bug, but am I doing the same thing multiple times? No, I don't think so. I am doing more than it. Let's take a look at. Let's convert this to a list for debugging. Okay, fine. All right, so then now this is okay, and then we print answer maybe. Yeah, I figured this wouldn't really fly. Whatever. It's okay. So there are a lot of these. How many nodes are there? Jeebus. Doesn't even want to print out all these. I could remove these. I think it'll print a little bit more, but nope. At least they are consistent, but one none is pretty big though. It's because it's trying to print each of these in a line, but okay. So what I'm doing now is just trying to see whether it's matching something not quite right. Do I do anything? No, none. It should be okay. If this is a leaf, leaf should be okay too. So all these are leaves, right? Already I think we're seeing something weird. So which is good. Maybe. Because this one, and maybe this is just luck, has 0 and then the right is 1 and this one, right? So that is a little bit awkward, right? Why does this map to the same thing? Oh, wait, do we? No, we add 200 here, right? Basically this thing, right? So basically there's a node with 0, left, no left, 1 right. So let me actually, we can create this test case actually. Think 1 0 1 maybe. Nope. Something like that, right? And then now, oh no, that's not right. What? Maybe we do something else on the left side, which is 1. Nope. No, 1. Something like that, maybe. But that's what that other thing was saying. Kind of. Like this is one list. Because we're duping too much. This is another, where was that other thing that we saw? Sorry friends, this is a struggle today. But I mean, I think the idea is right. It's just I'm being very silly with the debugging. Though I don't know what's wrong with this, so that is definitely a little bit tough. But this is just a little, no, is it? This is kind of very hard to read actually, so. Except for, I think this is a comma, but then like the next note starts at 2. So is it just false positives? There must be a smaller example, like the one that we had before. If length of v is greater than 2, because a lot of these other ones don't make sense. I'm trying to find the one that we had before, but alright. So these at least match. This at least match. Okay, so then maybe we can do for x in v, we'll put string v. Just for, I just want to see whether stringsify correctly. So then it's stringsify like this. So then now we can maybe do something like print if set of string x for x in v is if the length of this is greater than 2, then print v. Right? So the string, because the stringify is the better one. So this is definitely doing something. So my math is doing something really wrong. So yeah. Because for example, then is this a smaller example? I think is the comma the right thing to delimit on? I think so. This one the root is 6 and this one the root is 9. Is it just like I mean, some of these match, but 9 with a right on a 2 is the same as 6. So I guess we're just like having false positive all over the place. So in theory it is correct. So tell that to the interviewer, right? Okay. But we changed some stuff and it didn't really change it. Because usually when you play around the constants, it usually should be okay. But maybe this form is a really bad, because this is no longer b. Maybe we can do something really big. It's still wrong though, but Larry. But yeah, this is 7, right 1, 7, 1, 9, and then this is 7, 1, 8. My value is like really weird. What am I doing? How can that be right? Like, am I just that unlucky with the things? Because this is just happening everywhere. Because this is 7, 1, 9, and then 7, 2, 8, right? Yeah, okay. Let's 7, 1, 9 and 7, 2, 8. What? Seven, 2, whatever. What are you doing? What? Oh. 2, 8, right? And then 7, 1, 9 is the other one? Okay, right? And then 7, 1, 9? Right? Well, why does this give me the right answer if Am I doing something really funky? Because that's twice that we isolated these, and then it just doesn't work. Yeah, huh. Oh, that's not true. It's just that... No, because it's not printing anything, right? Alright. Node and then V, right? Oops. So where's the 719 case? I think it's near the end. No, geez, this printing is terrible. I mean, don't know. 729? No, this is on wrong 729. Oh, because I'm printing a lot more, that's why. Wait, let me look at the other one then. This is a little bit of a mess. 729 is this big number, and then 718 is also this big number. How is that possible? No dot value. Also, if they match, then how come I didn't get... Oh no, because I'm printing nothing for the answer. Okay, I'm being silly. Huh. Why is that? Two 8 and 1 9 is giving me the same number. 2 times b plus 8? Huh? Okay, so the root is... so it's 202 times b plus 8. But it's not 8. It's 8 shifted, more stuff. Oh, huh. I'm doing some silly thing, I think. Because now... because right gets shifted twice in the recursion. Huh, okay, I get it. But that's... wow, Larry, you're being dumb today. Okay, how do I do this? And the reason why it works is because now they're offsetted by the same amount. Okay, I get it. I get why my false positive is really, really, really bad. Okay, let me think. How do I address this? How do I want to address this? Usually formulas like this is okay, but maybe not. Maybe I can just do something like... now XOR is not y. Because then now you have left, right, that's not the same. So right gets shifted twice before. And then this gets whatever before it gets shifted. That's probably why. Maybe I just needed to do it the other way. Maybe I got confused. I mean, I have to kind of fix the rest of the code, Larry. Yeah. I think maybe I shift and added the wrong way. How do I add the test cases? Whatever, YOLO. Oh no. There's still something to it. False positives are tough. I just want to double check real quick that it is... I mean, I am definitely doing more. Basically this one, 65566. 65566. How does this tree even look like? How do I copy this? 65566. Oh, I think the base is too high really though. So it's just from before when I was confused. Still not right though. It's the 65566 thing. It's so hard to kind of just check on these because of the visualization. Maybe I should have done it with the string matching instead. No, is this 700 now weird? Maybe. Really, it doesn't really matter what I choose. So that means that there's a bad hashing somewhere in this fingerprinting as well. What would make this 65566? What is okay, fine, let's do it again. Why didn't I save that code? Some days you feel like a king and some days you have stuff like this where you know how to do it and then you just kind of do something silly. I might not print. Okay, that's so you have this thing. This is, I forgot, this is the same. Okay, so the 6. Oh, because only it prints out the second one, but I guess I just have to do it this way. I'm looking at the wrong one again. Okay. All these looks good so far. We were looking at the 6555 thing, right? So it should be this one. 656. No, 666. No, this is just 666. Where's the one that is giving me the wrong answer, which is 65? No, this is just 65. Sometimes in life and learning, you just have to grind. And this is one of those sad times. Okay, so is this the one? I think this one's the different one. It's 65665, which matches 65476. I need a paper. I can't really. That's my notebook. I think that's what I get for trying to be too clever, I think. But I am getting a pencil. Super pencil. Nope. I know that right now I should YOLO and just do the stringify thing. But I'm going this far. Alright. Let's see if I can understand this. 6 left is 5, left of that is 4, and then which right is this? Is the 5's right have 7, and then that has a 6. Okay, and then now 6, 5 has a 6, and then the right has a 6, 5. Do they even have the same number of nodes? What's going on? 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. They do have the same number of nodes, so I drew it a little bit crazily, maybe. No, I think I drew it incorrectly, that's all. But I mean, I could believe it. I think this is like some commutative type thing, because we're bubbling up things and then we're just adding. I see what's happening. We're basically adding branches from different things and not really combining them in a way. So then now basically the idea is that that we have multiple children. Then you have like some A plus B on the same depth. And on the same, thing, and then they now bubble up in the same direction. How do I do this? I have done this in the past. Why am I struggling with the fingerprinting? I think I did the fingerprinting the other way, but still. Because basically it's the same as if you do like just this, then left and right could be swapped without really, and that would really change the answer. But I thought this would work though, to be honest. But how do I change this so that this now works? Man, I am struggling today. I was very wrong, by the way. Just so it is clear that even Larry can be very wrong and spend 40 minutes on a medium. But maybe this is easier way. Oh, I guess maybe the easiest way is just string hashing. But how do you do it in a smarter way? Like if I were to do it, how would I do it? Like, clearly this doesn't work, but that's the only thing that is. Okay, let's just leave this for now. I mean, that's the only thing that's like messing it up, but I don't even know how I would shift. I guess maybe how I've done this before. How did I do it last time? And squats really take it out of you. Basically, we have to make it so that the encoding is different. I'm encoding it in a really weird way. That is basically commutative. Right? Because basically, so how do I do it? I thought this was good enough, but it doesn't, because all I'm doing is shifting, and then now some of the shifting is is giving me a false positive under the mod space, or the might have P prime. Man, today I'm just struggling. I mean, I'm tempted to do something like this and then see what happens, but well. Just to kind of make it an order a magnitude difference, but learn. But yeah, I actually was thinking about this earlier, but I just wasn't able to convince myself. Basically, what you want to do is make it so that the addition isn't swappable. Because the idea, and I'm kind of hand wavy a little bit, but I just wasn't able to prove it. That's why it took me a little bit. But basically, you have something like A times B plus B. No, this is terrible. That's just X and Y, right? X times B plus Y, say, times B. So then, like, you know, there's Z plus this thing, right? And then the other one, and then now let's say you take this and then you shift it by B because it's on the, yeah, I mean, and then basically the reason is that if you have one more layer, like let's say this is the left side and then it's just B times this, but then I don't think I'm saying it right, but I get it, kind of. It's basically because of the because if you have if you have something that looks, yeah, and I guess the mod would get rid of it, but or the power gets rid of it. Well, kids, this is why I'm not going to teach Robin Cobb, but clearly I don't have a good understanding. No, I mean, I think now I understand why, but I think I understand how I made the mistake, but also honestly, it's not a good enough understanding that I can explain it clearly why I was wrong. But basically, you have the way that I would maybe think about it, if you wanted to see what went wrong with Larry, was basically that it was taking sums of linear components. So then, yeah, maybe like if we have something like this, you know, this is just Z times B plus X times B times B plus Y times B times B times B, or something like this, right? But then maybe, or maybe, I think the way that this was done is that maybe if we have something like this, we can really differentiate this part with something that goes on the right, and then just like, you know, with the same number. So that would already be a little bit off, maybe. I don't know. I'm not really explaining it right. And the reason, and the reason why I kind of have a hunch that this would work, but wasn't still sure, is that I'm good enough in math to, or not good enough in math, but experienced enough in math to kind of know like the order. Now this gets rid of this commutative thing, right? Like there's some B that kind of is it commutative or distributive? Maybe I've been saying commutative wrong. I mean, obviously addition is commutative, but I think there's some distribution or distributive property where it just kind of messes it up. But once you multiply, now you have a different order. So then now it's, I mean, there's still maybe false positive, but not in quite the same way where like if we just change the order of some additions, it's basically what we were doing. Because basically, this is not good enough as a proxy because you can have two things that are on the same level and then add each other in a bad way. Just looking at my graphs. That's kind of the idea. But yeah, I'm experienced enough to kind of have a hunch that this works because now you can say that it is a higher order thing. But Also, I would say that is not a humble brag because what I was going to follow up with was not good enough to prove it to you or show you how. So, all right, that's all I have for this one. I think for fun, now that we got it correct, and it took so how long is the video? 45 minutes. So we got the first answer in about 10 minutes, but really struggled with the math a little bit. So let's kind of see if we could have done something like string of node and then see if that would have been fast enough. I am curious. Did I print anything? No. Because I was thinking that, oh, okay. So at least that is correct in that that does time out. So at least we didn't waste any time doing the timeout way, I suppose. Yeah. I'm just thinking real quick whether you could make this slightly more optimized, but yeah, because now this is n square. Maybe if you pop it up, would that be n square or would that be n? If you share space, maybe it'll be O of n, but I don't know because this scene thing is still pretty expensive. So, yeah, I don't know. Anyway, that's all I have for this one. Let me show the code real quick. Yeah, so this is. Let me go for complexity real quick. Sorry, friends. I'm really tired. Actually, I'm not so tired, but just like mentally fatigued. Those squats, they really take all the blood out of my brains, as they say. But no, yeah, this is linear time, linear space. Even though answer has a bunch of stuff, you can only add each node once, right? So that is going to be linear space. Same for scene, and everything is just a depth of search. So yeah, linear time, linear space, and that's all I have for this one. I think this, but I think this is actually more correct. But let's make it go any faster. I mean, not really, but okay. Yeah, that's what I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.